So I mentioned we're going to be pulling some data from a website that's out there, openweather.com. You may be familiar with it. They expose a free API to pull some weather information. We're going to be feeding that data through the OPC router, and then we're going to log that data both to SQL, and we're going to be pushing it down to a OPC server, which is our top server in this example, and then pushing it down to some PLCs. So with that being said, let's get rid of the slide here, and let's jump right into the router piece of this. So I'm going to do a little basic introduction, but for the most part, I'm going to assume just a general knowledge of what components are. Like John mentioned, we did do a training a few weeks ago on OPC router basics in the introduction. So definitely let us know if that's something you're interested in, and we can get those links and those recordings to you. But as is pretty standard with the OPC router, the first thing that we want to do as we're approaching this configuration is we want to configure the plugins, which is going to be where the data is coming from and where we're pushing it to. So in this case, we're pulling the data from a REST API. So obviously, we want to do this REST tab, and let's add a new API here. So it's worth pointing out at this point, the focus of the training today is REST. There's obviously a lot of other API-based protocols out there. We can do SOAP, we can do MQTT. So we're focusing on REST today, but for future trainings, we will likely look at some of these other protocols. So that's a common question that comes up in these trainings. So I figured I'd throw that out now. Actually, we'll take a step back before I configure this REST plugin. Let me pull up the API documentation. So typically, you'll see this with APIs like this, where you have documentation available and what endpoints are available and what the format of the data is. And the endpoint that we're going to look at is this API call right here. So you can see there's a URL component that we're hitting, and then there's a few query parameters after this question mark that we're passing in. And with those query parameters, we're going to be able to regulate what location we're pulling the data for, and that's also going to be where we pass in our API key, so the authentication piece happens here. And then this is actually the same one we're using, so we're passing in a city ID, which I have off screen already, and then an API key. The only piece here we're not currently showing is I'm actually going to be passing in units as well. So this API defaults to the Kelvin for temperature, which takes me back to my college days, but I don't know much to do with the Kelvin, so we're going to be changing those units a little bit. So back to the router. How do we configure the connection to this open weather API? So the first piece is we want to give this a name. Demo REST client. This is going to be how we reference this component later when we're using that in our connections and our data flow. And this host URL is going to be this beginning piece here, everything up to the .org. I'm actually going to copy and paste that right here, and we'll just add the HTTP. And that's easy enough. So Open API file is not going to be required. Open API, if you're familiar with it, is a standard kind of to try and standardize how these APIs expose data. Not necessary or required. For authentication, we do support authentication. This website specifically doesn't require it. They handle all their authentication with that API key that I showed. So for now, we don't have to worry about how we're not passing any username and password or anything like that. So that's actually all we have to do here. So if I hit OK here, that creates our demo REST client. And now the other two pieces we want to configure are our OPC UA server connection and the SQL server connection. So same as with the REST client, we'll add a new SQL server here, SQL server, and I have a SQL container running here locally. So we'll just authenticate with that. Be able to pull our databases. I have my router database. Perfect. I can check to make sure that that connection works. But since I was able to pull that list of databases, we can be pretty sure that it's authenticating successfully. That's all that's needed there. We're not worried about what table we're pushing the data to yet. We're just wanting to define that there's SQL server out there that we're going to be communicating with. And then the last piece, we're pushing data to a OPC UA server. So just as with the first two, we're going to be, need to define an OPC UA connector here, UA server. And here, define our endpoint. The rest of this should be fine, but just to make sure, let's check our connection, make sure I can get to my server, and I can. So just as with the SQL server connector, at this point in the configuration, we don't care what tags are out there. We're just wanting to define that there is a UA server in our network that we're wanting to communicate with. Let me hit OK here. So we've defined our three plugins. We've defined the REST client, we've defined the OPC UA server, and we've defined the SQL database. So moving right down here, let's define a connection here to play with now. So we'll add a new connection to a REST client. And it's a blank workspace. We can now go and add some of these transfer objects to actually do something with that data as we're processing it. So the first thing, of course, will be our REST client. So I'll just click and drag that here from our toolbox. And then we also have a database that we're interested in. And we have a OPC UA server that we're interested in. So I'm just, for now, going to click and drag those three objects to our work area here. So let's configure our REST client connector first. We'll double click that, and we'll want to bind that to our demo REST client API that we configured earlier. And if we look at the URL here, that's going to be the next piece of our URL here. So we're just going to grab the rest of this. I'm just going to paste that right in here. Now, the method that we're using is a GET, so where we're trying to pull data away from that or out of that API. And then we can specify specific headers in our request. And this is going to be where we specify those query parameters that I've pointed out in the documentation. So if I pull that back up, we have one that's called ID. We have one that's called app ID. And then there's one that's not shown right here. It's called units. And so I just want to specify those here. So we have ID, and that's going to be a query parameter or query string, not a HTTP header. We have one that's called app ID, and same deal. That's a query string. And then the last one we have units. And I'm going to go ahead and hard code this to Imperial. That's also a query string. So from here, that's really all we need to do. If we hit test now, we can test to make sure that we've configured this connection successfully. And it's first going to ask us to provide these empty fields that I didn't hard code in the header. So ID, and let me pull up my notes here. Pull this off. So ID is going to be pull that from the website, but passing that in, and then my API key I also saved off screen here, so I'm just going to paste that in. So now we have a well-formulated request. I'm just going to hit send, and let's make sure that we're getting something back. So you can see that we got a JSON payload in response. For now, we're not too worried about what we're getting back here, but I am going to go ahead and copy this to the clipboard because I'll show you a little trick here in a second that it'll be nice once we have this copied out. But the key is that we were able to hit the server and get a response back. So we're already talking to our API. Now, so yeah, hard code this in here. Not required. We can dynamically pass these values in. We'll go ahead and hit OK here. So our REST object is now configured. So the output of this REST client object is going to be that JSON payload that we just looked at. So from here, we need to parse that JSON to actually get at the data attributes or the data objects within that payload. And we have two transfer objects over here on the right. The first is JSON read, and the other is JSON write. So the question always comes up, well, what's the difference? The difference is direction of that JSON payload. So JSON read will go from a JSON payload, so that big mess of a string, and let us parse out individual data objects or data pieces. The JSON write is going the opposite way. So whereas the JSON read deconstructs a JSON payload, the JSON write lets us construct a JSON payload and then post that out. This case, JSON read, so let's go ahead and configure that. Right now, it's a lot of blank space, and this is where the little trick comes in. If I hit edit here at the bottom, and I just paste in that payload that I grabbed from the REST client, and I hit edit again, look at that. The OPC router parses that payload for me. I don't have to do any of this manually. So from here, I can select what data objects I'm actually interested in. So for the sake of this demo, let's pull our pressure, our humidity, and our temperature. Those are going to be the three pieces that we want out of here. Obviously, I have access to all the other stuff, but for now, let's keep it simple. Hit OK here. And you can see that this object now takes a JSON payload as an input or JSON document, and outcomes are pressure, humidity, and temperature. So from here, I can just draw a line from the body over to that JSON payload. So whenever this REST client hits the API, that resulting JSON payload gets passed to the JSON read object. So now we want to do something with that data naturally. So let's configure our UA connector. Same deal, we want to bind it to an instance. So we have our demo UA server. And if I browse for some tags here, I have a channel already configured. And fortunately, we have humidity, pressure, and temperature already here. And just because I'm actually going to pass some data to this result code as well. So now that I've selected these tags, I'm all set here. And I can just draw arrows just as with the other JSON object. I'm going to draw these arrows down, showing that when this parsing happens, we're going to push these resulting values to our OPC UA server. This result code, I'm actually going to grab all the way over here. We're going to pass that right over. These things don't cross too much. That way, the resulting query, if this query were to fail, we can see that based on this result code that gets passed through. And the last piece, we're going to configure a database connector. So we have our demo. It's complaining not all these databases exist. We have a demo SQL server. We want to insert the data, and I've already built a table here for the weather data. So we have some columns defined. So we want the temperature, we want the humidity, we want the pressure. I'm going to log the city ID. The way that I have this table set up is that log time gets applied by SQL, so I'm not wanting to pass any data to that. We can hit OK here. And just as with the OPC UA object, it's just a matter of binding these data points together now. The city ID is going to be coming in here in a second. So let's add some constants. So I mentioned earlier that this ID and the app ID can be provided dynamically. I can hard code it in. In this instance, I'm just going to supply those as constant values. But we do have the flexibility to pull those from the database or PLC to where you could now dynamically change what location you're pulling the weather data for. I'm going to add here. Enough. In this case, they are going to be constants, but they don't necessarily have to be. So our city ID or app ID in our units, pass those in. Take a little space here. Our data flow is set up. The only thing that's missing now is we need to add a trigger. So if I scroll all the way to the bottom of our toolbox, we need to add some sort of trigger that's going to tell this when to execute. So I actually have a trigger set up in my PLC that's changing every 5 seconds. I'm going to set up this data change trigger. But we have timer triggers. We have all sorts of triggers, database triggers. Effectively, I could do this with a 5-second timer trigger as well, but what fun is that? So we have a demo UA server here. We're going to browse for our item. I have this trigger item. Closed. And because we're hitting an API, I'm always sensitive on how often we're hitting that API. So at most, I want this to trigger every 30 seconds so we don't activate this and accidentally query this API every millisecond or something ridiculous. So we have our data flow built. The only thing left to do now is we need to set this productive. So let's do that. We have our staging area to let us review what our changes are. And now I just hit the Go Productive button again, and we'll push this to the runtime service. So it's telling me because I've configured new plugins that runtime service needs to restart, which is fine. Let this up here. All right, excellent. So we've pushed it to the runtime service. So now I can come down to our state monitor, and we have our connection set up here. So it's going to take just a few seconds to initialize. And once it does that, we'll see that every 5 seconds we'll see these data values transfer. So you can see the initialization is happening, and what we're looking for is a little green dot to show up in the state monitor, which will let us know that the data transfer is happening. All right, perfect. There's a little green dot, and we can see as that dot executed or popped up, we start seeing that now all these arrows are showing us what the values are that are getting passed around. We can see our constants are getting passed through. Here's our full JSON payload, and then that goes into our JSON read object, and out come the 3 values that we're expecting. This was up at 94% humidity this morning, so I'm glad that it's gone down a little bit, but you can see 81 degrees Fahrenheit. And even though this is executing every 5 seconds, it is at the end of the day a temperature, and fortunately Matthews here in North Carolina isn't having horrible temperature swings right now, but it is firing every 5 seconds. So how can we confirm that? Well, let's take a look at this database object. And pull up SSMS. We have our weather data table here. We can see, oh, I forgot to hook up my city ID. Oh no. Let's fix that really quick, just so we don't have any null columns there. Not that it's a problem, it's just not what I want. So I have my city ID here under my constant, so I'm actually going to drag that all the way over to my column here. And I just need to do a quick redeploy so we can see all the yellow objects aren't being changed. The green object shows the new addition. So let's deploy that. Sorry about that. Come back to our state here. It'll just take it again a second to initialize, and you can see that's now being pushed over. And if we jump back to SSMS, there we have our city ID now. Thank goodness. As we refresh this, we should see that roughly every 5 seconds we'll see a new entry added here. I'm currently still initializing, which can take a few moments. Once that fires, though, we'll start seeing the new items appearing here. There we go. Rattling off now. So there's our second value. And now every 5 seconds, we'll see a new value here. Roughly. Let's say change, give me a second. Sure that my trigger's firing as expected. Oh wait, close to every 30 seconds. I'm sorry, yeah, the fastest this will ever fire is every 30 seconds. So our data change trigger is actually limiting us here. It's doing what I told it to do. So every 30 seconds, we expect to see a new value, and we see that being the case here. So that's now happening.